Hello, my name is Ms. Midha, and today we are going to be looking at the following question. How are unit circles related to trig functions and real world problems? So we're actually going to be looking at a real life situation in a moment, and we're going to try and see if we can figure out how to model this situation with a trigonometric function. So here goes. This is the problem. Okay, it says, the ocean tides near Carter Beach follow a repeating pattern over time, with the amount of time between each low and high tide remaining relatively constant. On a certain day, low tide occurred at 9:30 a.m. and high tide occurred at 3 p.m. At high tide, the water level was 12 inches above the average local sea level, and at low tide, it was 12 inches below the average local sea level. Assume that high tide and low tide are the maximum and minimum water levels each day, respectively. Okay, so we have two things we have to do. First thing says to write a function which models the water level, f of t, in inches above or below the average Carter Beach sea level as a function of the time measured in t hours since 8:30 a.m. And then our second question is asking, at what time will low tide and high tide once again occur? And to explain our reasoning. So I am going to ask you to pause the video for as long as you need to see if you can come up with the answers to these two questions. I also want to just make a couple of notes before you do pause this video. So one thing to just keep in mind when it's saying the average local sea level, the average local sea level is at 0 inches, right? The local sea level is sea level, so it's 0 inches, the water level. And so when you're at high tide, it's going 12 inches above that local sea level of 0. And when it's at low tide, it's going 12 inches below that local sea level. So just keep that in mind. And then another thing to note is that this question is asking to write a function which models the water level as a function of time measured in t hours since 8:30. Okay, so just a kind of hint for you right there, just keep that in mind. It is at 8:30 and we note that low tide occurred at 9:30. So again, pause the video, take as long as you need to answer this question, these two questions, and when you think you have it, go ahead and unpause the video and we will review. Okay, so what I've done here, it's the same information, but I've just added a graph because we are going to want to graph this function eventually, and hopefully graphing it will actually help us figure out what we need to do a little bit more. Okay, so the first thing that I'm going to do is really kind of work through the problem itself. There's a lot of information here, so I'm going to sort of dissect the pieces that we're given to help us figure out how to write this function. Okay, so first things first, we are told that low tide occurred at 9:30 a.m. And we're also told that high tide occurred at 3 p.m. So right away, when I'm seeing these times, I'm thinking, okay, how much time has elapsed from low tide to high tide? Right? That'll sort of help me see like how long a full cycle is and things like that. So from 9:30 a.m. to 3 p.m., how much time has elapsed? Well, 5.5 hours. So this tells me one full cycle, right? One full cycle means I'd be going from low tide to high tide back to low tide. This actually tells me right away that one full cycle is going to end up taking 11 hours. Right? Because it took 5.5 hours to go from low tide to high tide. That means that to go back to low tide, it'll take another 5.5 hours. 5.5 plus 5.5, or 5.5 times 2, gives me 11 hours. So that's the first thing that I notice right away. Okay, what else is it saying? It's saying at high tide, the water level was 12 inches above the average sea level. And at low tide, low tide, it was 12 inches below the average sea level. Okay, so what is that telling me? Well, that tells me my amplitude, right? If I know that my average sea level is at 0 and it's going 12 above and 12 below, that's telling me that my amplitude has to be 12, right? The distance between the midline and the maximum and the minimums. It's telling me that low tide and high tide are the maximums and the minimums. So I know right away, oh, okay, my amplitude has to be 12 inches more specifically. Okay, so that's the information that we have so far. Okay, well, now what's next? Well, the next thing we probably want to do is figure out what kind of function are we writing, right? Is it going to be a sine function? Is it going to be a cosine function? And before we do that, you also want to just make sure that you know what each of your axes represent. Super, super important to understand what your axes are going to represent, right? That'll help you really understand how this graph will essentially look. So if I look at the information, and again, I look at the question itself, it says write a function which models the water level, f of t, in inches above or below the average Carter's beach sea level as a function of time measured in t hours. It's a lot of information. But by reading that, I'm able to figure out that my x-axis, in this case, we're going to call it t, this is the number of hours, right? Our x-axis, in this case, we're going to be using t, that represents the number of hours. Okay. Now, what is f of t going to represent? Again, this is f of t. I know that's a little hard to see. F of t, what it's really going to represent is the height of water, right? It's saying which models the water level in inches above or below the average sea level. So we're looking at the height of water, and again, it's going to be in inches. Okay, now why am I putting that in? Well, this is going to help me visualize what this graph is going to look like. Now that I know what my x and my y axes represent, I know actually what this curve will look like, if you will, based on the information. Because when I read this again, I want to remind myself, okay, low tide started at 9:30. Low tide is what happened first, essentially, in the situation. And so low tide is 12 inches below. Okay, I'm not going to graph it directly on this graph right now. I'm just kind of going to think about it visually. So if I sort of think about this in my head visually, if it's happening below, right, it's happening 12 inches below, it's happening at the lowest point of my function. Then at 3 p.m. it moves, so I'll just pretend this is 9:30, by the way. At 3 p.m. it moves to the highest, right? So notice what I just did. I just drew a point that's way higher than my low tide. This was 3 p.m. And then at some point, which we're going to figure out in a minute, at some point my low tide starts again, and it's going to be at the minimum value, right? So I went at 9:30 from my minimum, 3 p.m. to my maximum, and then to another certain time back to my minimum. So if I just sort of connect these, what kind of graph is this? It's a cosine graph. Okay, so I have another piece of information here. I know I'm going to be using a cosine graph. What kind of cosine graph, though? Right? Look at it. It's starting at the minimum value and not the maximum value. This immediately tells me, oh, I'm going to be working with a negative cosine graph. Okay, we are almost done with the information we're given. We're almost done sort of like dissecting what's going on. Okay, the other thing to note, right? I was mentioning, oh, at some point we'll figure out what time that is. Okay, well, let's think this through. If it takes 5.5 hours to go from low tide to high tide, how long is it going to take to go from high tide back down to low tide? Well, that really is going to be another 5.5 hours. So that's telling me my next low tide is going to be at 8:30 p.m., right? Why? Because it takes 5.5 hours to go from low tide to high tide. We're at 3 p.m. at high tide. It's going to take an additional 5.5 hours to get back down to low tide. Now, using that same logic, how long is it, or not how long, but what time will this reach high tide again? Well, what's 5.5 hours after low tide, right? Take a minute to think that through. I know that kind of gets a lot. 5.5 hours after 8:30 p.m., that's going to be 2 a.m. So my last high tide, not my last high tide, but my next cycle of low tide and high tide, low tide will be at 8:30 p.m., high tide will be at 2 a.m. Okay, so I actually ended up answering number 2 before finishing number 1, but that's pretty great that we have that idea in our mind. Okay, now what other information do we need to write our function f of t? I can see we have our amplitude, right? We kind of know what our midline is already based on what the situation is giving us. We can tell that our midline is going to actually be 0. And we also know that it's a negative cosine graph. Now let's focus on this part right here, this full cycle being 11 hours. Because telling me that this full cycle is going to be 11 hours, this is actually going to help us figure out our frequency, right? We're actually going to be able to figure out B in this equation, that letter B, because a full cycle means that we are going from low tide back to high and then finishing at low tide. right? So our full cycle, our negative cosine full cycle is going from min to max to min, or min to midline to max to midline to min, right? So how long does that one cycle take? It says it takes 11 hours. So if our full cycle takes 11 hours, that's telling us that the period is going to be 11 hours, right? Now, how do I find the frequency? To find the frequency, I essentially just take my full cycle or my period of 11 hours and I use that formula, right? If I'm looking for frequency, I use 2 pi over 11, right? I take that period, it's 2 pi over b. I take that period of 11 and I just put it in the denominator. So this is telling me that b, or my frequency, is going to equal 2 pi over 11. Okay, looks like we have everything we need. Almost. There's one more piece of information that is incredibly important. Notice that it's asking about writing this function as a function of the time measured in t hours since 8:30. It's not starting at 9:30, right? It wants us to look at it since 8:30 a.m. So if I think about this, 8:30 a.m., this is where my graph is going to start, right? And I'll actually mark that up in this graph over here. I know that this point right here at this 0 mark, it's really going to represent 8:30. That's my initial time. Since my t represents the number of hours, really what's happening, it's the number of hours after 8:30, right? The number of hours after 8:30. So how many hours after 8:30 is 9:30? Well, it's just 1 hour, right? 1 hour after 8:30 a.m. is 9:30 a.m. So what's going to end up happening, and this is just a sketch, I'll mark up the graph a little better in a few moments, but what's really going to end up happening is that if my origin represents 8:30 a.m., 9:30 a.m. is going to occur when t is equal to 1, right? 9:30 occurs when t equals 1, and at t equals 1, at 9:30 a.m., that's when my low tide starts, right? And let's just say my low tide starts, let's just say this is -12 for now. Again, I will fix this graph after, but let's just say -12 starts down there. So this is telling me that there's actually a horizontal shift, right? There's this translation of my negative cosine graph to the right by 1. So we also have to account for that when we're writing our actual equation, right? We have all of the pieces now considering that our actual cosine graph is starting to the right by 1. It's not starting at 0 comma -12. It's starting at 1 comma -12. So how do we write all of this in one function? Here we go. I'll go back to blue here. F of t. Okay, first things first, we got to write our amplitude. What's our amplitude? It's 12. We also know it's a negative cosine curve. So we're going to write -12 cosine, because we know we're working with cosine. All right. What is our frequency? Our frequency is 2 pi over 11. And we are writing this as a function of the time measured in t hours. So we're going to write t. But again, remember, there is this horizontal translation. This graph has been translated horizontally by 1. So we need to indicate that here in parentheses. So we write t minus 1. Now there is no vertical translation here, right? The midline is just at 0. So that's what our function is going to be. F of t is equal to -12 cosine, parentheses, 2 pi over 11, parentheses, t minus 1. That's a lot, right? A lot is going on here. But again, notice what we did. We really broke this problem apart. We looked at the times first. That helped us figure out how long one full cycle is, which led us to figure out our frequency. We also looked at the heights of our high tide and our low tide. That allowed us to figure out the amplitude. And we also kind of made a sketch of the graph before actually placing it on this, this graph, which we'll do in a moment. And that really helped us see that it was going to be a negative cosine curve. Okay, our next step, I know it doesn't say it on here, but our next step is to actually graph this function, right? Graph this function f of t. So if you didn't try to do it already, that's okay. I'm going to ask you to go ahead and take a few moments. Again, pause the video for as long as you need and see if you can actually graph this function. I'm going to go ahead and start doing that right now. Okay, so I want to just remember that my T represents number of hours, and more specifically, it represents the number of hours after 8:30. Since I'm going to be dealing with at least 11 hours to draw this cycle, I'm going to just scale. I'm going to keep the scale of 1, but I'll move 1 over here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. And we'll just stay with 12. Okay. Now it's saying the height of the water. I know my max is going to be 12. My min is going to be also negative 12, or rather negative 12. So I'm going to set this, I'm going to write this by 2's. So 2, 4, 6, 8. I'm going to scale it by 2's. Okay. And I'll go the other way as well. But now that I have that, now I can just sort of think about the points, again, from the problem, straight from the problem. You can look at the equation too, of course, but you have this information from the problem already as well. So again, I know that 1 hour after 8:30, right, at 9:30 a.m., I know that my height of my water is going to be at negative 12. So I know there's going to be a point down here. And I also know that at 3 p.m., my height's going to be 12 inches, positive 12. So how many hours after 8:30 is 3 p.m.? Well, that's 6.5. So what I'm going to do is I'm going to look for 6.5, and I'm going to plot a point at 6.5, comma 12. Okay, now reminder, where was my next low tide, right? I want to finish the cycle. The next low tide was going to be at 8:30 p.m. How many hours after 8:30 a.m. is 8:30 p.m.? Well, that's going to be 12 hours. So we'll go ahead and make that point here too. Okay, now again, notice that I have my minimum, my maximum, and also my minimum. So I almost have the entire sketch of this graph, but I do also want to kind of think about some other points that may occur. So let's just sort of think this through for a second as well. So this is a little hard to sort of think it through, but if I look at the distance on my, my t axis, if you will, between the minimum and the maximum, I can see they're 5.5 units apart, right? So if I'm trying to figure out, well, how do I go directly in between that? I'll notice in the end, it's actually going to be hitting 3.75. It's going to actually hit the 0, right? The x-intercept at 3.75. So I'm going to make a little point over there. And then I also know going down, it's going to hit at 9.25. Again, right? And you can pause the video and sort of see if you can figure out why that is conceptually. So now I've got my cosine graph. Let's see if I can make this. It's not bad, right? It looks okay. All right, so this is my cosine function. Again, my actual function f of t is equal to negative 12 cosine 2 pi over 11 t minus 1. And when I graph it, it's not the greatest graph, but it's hopefully a good enough sketch of f of t. Okay, so I've gone ahead and just moved the graph to a new slide just so it's a little cleaner and we can see it. The function again, we have it written there, f of t is equal to negative 12 cosine 2 pi over 11 t minus 1. And so let's just answer these last couple of questions. What is our amplitude? So again, to remind us, the amplitude is going to be 12. It's the number in front of the cosine. And also we can see it's because the distance between the midline and the maximum, as well as the midline and the minimum, is in fact 12. Now our midline here, we can tell is 0, right? It's the halfway point between our max and our min. And our period, well, remember, the period is telling us how long it takes to complete one full cycle. And we noticed here our period was going to be 11 because first we can see it on the graph, right? We're starting the minimum value of our negative cosine graph at 1 and we're ending at 12. 12 minus 1 gives us 11. But also just to remind ourselves, when we had the time, we knew that one full cycle going from low tide to high tide back to low tide again is 11 hours. So that's how we take this giant real life situation and model it with a trigonometric function.